for lesson 4.0, reviewing some exponent properties and rules that will be useful in the rest of our chapter 4. So to simplify an expression containing powers or exponents, that means that all monomials, there are no powers of powers, each base appears only one time, all fractions are reduced, no negative exponents. To simplify a polynomial, simplify monomials and combine like terms. Right, so let's look at some examples of those properties of exponents that we're going to be using to simplify. Right, so if you have a base with an exponent times the same base to another exponent, right? So x to the a times x to the b. Right? Our bases are both x. And to simplify that, for product of powers, we are going to add those two exponents. Right? So looking at that in terms of an actual example, right? If I have n to the third times n to the fifth, right? That is going to be equal to n to the 3 plus 5. Which would be n to the 8th. Right? So product of powers means that you add the exponents. And there's where a little bit of the confusion comes in. Right? We see that word product, we think multiply. Yes, they are being multiplied here. But to simplify that, we are going to add the exponents. Quotient of powers, well, this was the opposite then, right? We have x to the a over x to the b. That's going to be equal to x to the a minus b power, right? Again, if I have n to the 7th over n squared, right, that's going to be equal to n to the 7 minus 2. And you may not write down this middle step here, right? You may just go, okay, I know that 7 minus 2 is 5. So that gives me n to the 5th. Negative exponent property, right? We cannot have negative exponents in a simplified expression. A negative exponent means that it is on the wrong side of the fraction bar. So that's going to come down here. So if I have n to the negative 4, that means it's going to be 1 over n to the 4th. Right? So in your simplified form, you cannot have negative exponents. The flip side of that, if you have a negative exponent in the denominator spot, right, that's going to mean that it's going to be x to the a. Right? So n or 1 over n to the negative 3. This term, this n to the negative 3, is on the wrong side of the fraction bar. So I need to move that to the top side of the fraction bar, which in this case means you have a denominator of 1. So the fraction bar is going to go away altogether. Power of a power, we have x to the a all times b. So that's going to be x to the a times b. Right? We never take an exponent and then take it to an exponent, right? The most we're going to do is multiply those exponents. So if I have n to the 3rd and then to the 4th power, that is going to be equal to n to the 3 times 4, or n to the 12th. Right? I did not take this 3 to the 4th power. Right? I multiplied those exponents. And I can kind of look at that in terms of an example, right? If I have 2 squared to the 3rd power, right? That's really the same as 2 to the 6th power, right? That would be equal to 64. And if I just kind of break that down, right? Again, 2 squared to the third. Well, 2 squared is 4, and 4 to the third then is 64, right? If I did 2 to the third, that would be 8, and that doesn't work, right? So we multiply those exponents together. Power of a quotient, to simplify that, we're basically going to distribute in a weird way kind of this a to both terms inside. So that's going to be x to the a over y to the a. Right? So if I had n over 7 squared, right, that would be n squared over 7 squared, which would be 49. So we're going to look at some examples using these rules. They're not going to necessarily all be in isolation, so we're going to take these a step at a time. There's no one place you need to start here, but looking at example A, I see a to the third times a squared times b to the fourth times c to the negative 1. Right, so as I'm looking, right, I see this c to the negative 1. I know that that term is on the wrong side of the fraction bar, so that c is going to drop below the c to the first, which we don't usually write the first powers down. So that c is going to be below the fraction bar. So here I'm going to multiply a to the third times a squared times b to the fourth. Well, a to the third times a squared, that is product of powers, right? So I'm going to add those exponents, a to the fifth, and then the b to the fourth is just going to move along. Nothing else needs done with that because it's already in its simplest form. Looking at example B, right, this is going to be quotient of powers. So this is going to be n to the 2 minus 10, which would be n to the negative 8. Right now I'm going to use that negative exponent property. I know that that negative 8, it means that that n term is on the wrong side of the fraction bar. So 1 over n to the 8. For part C here, we have some different things happening. The first thing I see is power of a quotient, right? So I'm going to have to deal with this exponent out here first. That means I am going to square everything inside the parentheses. So the 3 gets squared and becomes 9. A to the third squared, well, that is power of a power, right? So I am going to multiply those exponents, right? A to the third, and then the 3 times 2, right? A to the 3 times 2, which would be a to the sixth. And then for the denominator, right, I have b to the fourth and then squared. So that's going to be b to the 4 times 2, which is 8. For example 2, we are going to basically just be combining like terms here in example 2a, right? So I have a to the 2a to the third minus an a to the third, so that's just a to the third. 5a minus a negative 3a, so that would be the two negatives make a positive, plus 8a. And then negative 7 minus a 2 would be minus 9. For part B, 6x x plus 20x squared all over 2x. So what we can do is basically break this out into 6x over 2x plus 20x squared over 2x, and then simplify, right? So 6x divided by 2x, well, 6 divided by 2 is 3, and then the x over x cancels, right? X divided by x would just be times 1. And then 20x squared divided by 2x. 20 divided by 2 is 10. X squared divided by x is just x. Technically, for this to be in standard form, you would put the 10x first and then plus 3. For example 3, I would simplify the numerator first. So I'm going to say the negative 10, and then g to the 6th times g squared is g to the 8. H to the 9th times h to the 3rd is h to the 12th, all over 30, g to the 3rd, h to the 3rd. So now I'm going to start simplifying. I can simplify the negative 10 over 30, the g to the 3rd, or the g to the 8th over g to the 3rd, and the h to the 12th over h to the 3rd. Right, so we're just going to simplify like terms. So negative 10 over 30, the negative's going to stay, and the 3, right, negative 10 over negative 30 is really the same as negative 1/3. Looking at the g's here, g to the 8th over g to the 3rd, we're going to subtract those. That would be g to the 5th, and h to the 3rd, or h to the 12th over h to the 3rd is going to be h to the 9th. And that is actually as simplified as that one can go. That gets you ready to do the assignment for this lesson.